Well, good morning, everyone, and welcome to our Inauguration Day special edition of CPT 168. I hope you're all excited about the new president being inaugurated today. It's a historic thing. I get all involved in the pomp and circumstance of it. My family, my dad was a historian, my brother's a historian, and we come across these milestones in our history. It kind of gets me excited, and I'm looking forward to seeing the ceremony later on this morning. But we'll before we get that far in our day, we'll go ahead and do our class. A few things I want to talk to you guys about. One thing is that I went through the grade book this morning just to see how you did on submitting things, and it looks pretty good for this class. We have 20 people in this class. It's a full class, and everyone did a pretty good job of getting the assignments in, and also all but one of the labs. I mean, not a whole set of labs, but just one lab. One guy left off one lab. Where we have a problem is with the topics in the forum discussion. And I had the same problem yesterday with that CPT 168 class. And I think it is because you guys are not used to that type of assignment. So realize that every week you'll have a forum discussion to post. And then once you post your response to the question, then you can look at the other students' responses and pick three of them that you're interested in and reply to those with some comment or feedback on their post. The whole idea behind the assignment is to foster professional discussion, get you thinking about some of the topics that we're going to have to deal with in this class, and just help you get more familiar with the electronic medium that we have to deal with today, and discuss, talk amongst yourselves, get to know your classmates. So be sure and do that. It counts 10% of your overall grade in this class. So that is a big thing. You need to consider that each week too. It does count towards your grade. It's not optional. The other point I wanted to make is I got a couple of emails since our last class from students who wanted me to debug their code from lab 1-3 in the first unit. That was our first coding lab. For some reason, they were seeing an error, and so rather than figure it out themselves, they wanted me to do it. And I want to make sure everybody understands my position on this. We've got a lot of labs. We're going to do 34 labs apiece, and I got 72 students. There's no way that I can debug everybody's assignments for them. That is just impossible. There's just not enough time. So anyway, what I want to do is teach you how to debug your assignments so you can find the mistakes and sort through them. And so as we go through our chapters, I will continually talk about debugging and error correction and things that you need to look for. Normally it starts out as a syntax error, and later on in the course you'll get into more runtime errors and logic errors, and we have a whole unit on debugging and error checking. So it is part of the rite of passage to learn how to debug and fix your mistakes, and you need to start on that right up front. So I don't expect you guys to be perfect. I don't expect you guys to find them all, and so and I also do not expect you to spend hours and hours and hours on a lab trying to find a spelling error or a missed punctuation mark or something. That's unrealistic too. So give it your best shot. If you can't find the error, then take your lumps when the grading happens. But it's better to turn in an assignment with a error in it than it is to not turn in the assignment. And I will also point out something that you may or may not have discovered. But when you did lab 1-0 and installed the data files for this course from the publisher, you also got solution files for all the labs. So you should easily be able to look up the answers to your questions in those solution files. But my suggestion to you is to not be tempted to turn in the solution file for your assignment. I will figure that out pretty quick. So make sure you do your work in your style, develop your style. And if you run into a situation where your code's not working the way you want it to, take a peek at the solution file and see if that gets you unstuck. Problem solved. So I hope that that's going to work for everybody. And if you have any questions, send me an email, whatever. I'll be glad to tell you what I can. But anyway, I just wanted to clear that up. So let's go ahead and get started with our lesson this week. And let's see, I better go ahead and share my screen. I'm doing all this foolishness and it's only happening on my end. I need to make sure it happens on your end too. So let's see here. First thing I want to do is talk to you about our schedule. And so here we are in week number 2, unit number 2, week number 2. And this week we're going to discuss how to write your first programs. What you guys need to do is read and study chapter 2 in your book, do the topic 2 in the discussion forum. You have 3 labs and expect these labs to be a little bit harder than the labs last week. They definitely raised the bar. Lab 2-3 is going to be your first program that you write from a scenario that the writer of our book comes up with. These first 2 labs, you're going to be correcting code that's already been started. And also you have the Unit 2 quiz. Remember on the quizzes that A right there is for attendance. It is required for you to get the non-classroom attendance for our hybrid section. And that's the attendance I post on Sundays for Sundays. And so we had one guy that turned in his assignment late this week, and that hurt his attendance. So you're not supposed to turn in assignments late. He sent me an email, told me what the problem was, and so we went along with that. But my point is get them in on time, and remember you can take those assignments 3 times so that you can make a really good grade. You can make 100 on those by retaking those. And so most of you made hundreds, and that's good. But a few of you did not. And so I have to think, I wonder if they did all 3 of them. And I'll go in and look when I'm working on my grading. Tomorrow's grading day, by the way. Let's get the president inaugurated today and get a couple of classes done. Pretty busy day. And then tomorrow I'll concentrate on grading all day and get caught up tomorrow and Friday. So are there any questions about what's on tap for this week? All of your week number 2 assignments are due on this Sunday by 11:59, January 24th. Okay. So let's go ahead and get started with our lesson here. Unit 2 is an important lesson because it does a lot of basics. I think I told you last week that the first 8 chapters in this book really are the how to program the basics of Python. Well, out of those first 8 chapters, I think the first 4 chapters are critical. You really have to dig into the first 4 chapters and totally understand what's going on there so that you can be successful and productive in your latter chapters and get your coding skills up to speed. So really bear down on chapter 2. We're going to learn, and I mentioned this last week too, we're going to learn more about this indentation thing. Python requires that we indent our code blocks. And remember when we were talking last week, we compared Python to Java. And languages like Java use braces to mark the beginning and end of code blocks. And Python does not use those nasty in the way braces. It just uses a simple indentation. And so it is required. It's not optional. You can't use the braces instead. You'll get error messages. So just get used to indentation. And I think it's probably fairly safe to say that you can't really over indent, but you can under indent. So we got to be sure and work on that. Python uses the same commenting strategy as other things in Unix and Linux based languages. It works in Windows as well. We'll learn a couple of ways to do commenting. And from this point forward, after today, we're really going to expect you guys to document your code very professionally. We want you to comment each of the blocks and tell us what you're doing in those blocks. And if there's something particular to a certain line of code, we'll see how to do an inline comment that will help document your code so anybody reading your code can understand what's going on. Data types are serious business. We cannot mix up our data types. And for people that are just getting started in programming, data types are kind of an annoyance, but after a while, it's second nature. Strings are kind of our go-to data type. They're the most flexible. They're just characters. They don't have any superpowers of any kind. And so an str is a string, int is an integer, which is a whole number. And float is a float value or floating value. That is a decimal number. So we'll learn the differences between those data types and when we need to use a function to change data type so that we can get our code to work properly. Also in this chapter, we're going to talk about two naming conventions, both the underscore notation and the camel case notation for naming our variables. This is part of the style of programming. Programmers will develop a style of variable names and stick with it normally through all of their code, part of their signature, if you might have heard it referred to that way. And so we're going to look at the primary two, notation, underscore notation and camel case. I started out with underscore notation, and I've kind of gravitated to camel case because underscore looks a little bit long to me, camel case. When I see camel case notation, I know exactly that I'm looking at a variable. I don't have to think about it a whole lot. Whereas in underscore notation, it could be a string with underscores in there for spaces. So that to me makes it just a little bit confusing. We have to worry about that. We're going to start working on math this chapter and take a look at how arithmetic expression works in Python and the order of persistence. And this is very consistent. It's identical to the way it's done in PHP and other languages. So you may already know this. I want to make sure everybody in the class is up to speed on it. So which comes first, the chicken or the egg, is going to be our question there. We're going to understand the order of persistence, the order in which math is done, and then how we can change that order by using parentheses to break the persistence of order or to modify the persistence of order. We'll look at some arithmetic operators. Most of them we have used many, many times in our lives. There are a few that are a little bit different, and we'll take a look at those as well. Now, one of the really neat tools that we have in Python is a compound operator, the plus equals, minus equals, or asterisk equals operators. And these are operators that do two math things at one time. That's why they call them compound arithmetic expression. And so we'll learn how to use that, and you're going to love it. You're going to jump on it early and start using this in your code fairly early in your experience. Later on in the chapter, we'll talk about escaping characters to make characters literals rather than meta characters or keywords. Some people call it that. But escape sequences are very common in programming. And there's certain characters like a $ or an @ or a hash sign that have a meaning to the interpreter. And so rather than have that interpreter get all confused, well, there's a way for us to escape those characters and turn them into literals. So a £sign is just a £sign. It doesn't mean anything special to the interpreter. Another term for this are meta characters. So these are special characters, meta characters that have to be escaped. Then we get into the real fun stuff, the Python built-in functions. We'll learn how early on to write our own functions, but we're going to start off learning some of Python's built-in functions. This is why we are in Python class. Python has a humongous library of functions, classes, modules, and that's how we can use somebody else's code that has been written and tested and verified and homogenized and ready to go. And we don't have to worry about it. All we got to do is make sure we import the functions and use them properly. And so most of this course is about how to use functions. So we're going to start that process today. And we're going to learn 1, 2, 3, 4, 5, 6 functions today. The print function, input function, string function, float function, integer function, and the round function, and how to use those. And just to make sure we get a lot for our time today, we're going to learn how to chain functions where we can put one function inside of another function inside of another function and really write efficient code that does a lot of work without a whole lot of typing on our part. So it's time to get this thing started. The quickest and easiest way to learn Python programming is to do Python programming. That's kind of one of those duh statements, but it's true. That's why we have 34 labs in this class. I was talking to some of my colleagues online last week, and they were going on about their labs. And I said, well, you know, in Python class, we got 34 of those guys, and we're probably going to end up with more before I'm finished. And they go, man, that's a lot of grading. And I said, the only way you can learn this stuff. The only way you can learn Python is to do it. And that is what we're going to do in this class. Indentation, okay? The default or the best practice or our go-to number is 4 spaces. We want to indent our blocks of code and sometime our continuation of code. We want to indent 4 spaces. If we just indent 1 space, Python's going to throw an error. We're going to have to make it a substantial indent. So just realize it's typically 4 spaces, and we're going to see some examples of all this, a bunch of examples this week and in weeks in the future. Now, our lines of code, our statements are going to get long pretty quickly, especially when we start doing that chain functioning and putting functions inside functions. And so we're going to end up with something called continuation. And continuation simply is just breaking a real long line into smaller lines, but we don't want to break the flow of the code. So there's 2 different ways that we can deal with continuation of a really long line. One is implicit continuation, and the other one is explicit. In this class, I want you guys to use implicit continuation, and I'll show you exactly why here in just a second. Now, you can't just whack a line of code anywhere. You could break something that the interpreter is not going to appreciate. So we need to follow a couple of rules when it comes to implicit continuation and where to break a line. And so first off is working from the left to the right. Get past your first parens. That will be the first parens, the left parens in a function. Then you can break the line fairly successfully. Or, and this is a safe way, our example does this, break at a operator, either on the left or the right of an operator. That's a good clean place to break. Just realize if you break in the wrong place, the interpreter will not see the whole statement, and then you'll get an error message. It will not compile. So that's why we're sensitive about this. So after the opening parens or before or after an operator is really good. Now, the explicit continuation basically is when you mark, you put a backslash in your code marking the point where you break the line of code. And you're thinking, well, that's kind of a clean way to do it. And I'm not going to argue that. It's just it adds more code, and you really don't need to do that. So the only difference is you put a backslash in where you want to break that code. And I'll show you in just a second some examples of that. Last week, we talked about the shebang line in all the Unix-like operating systems, Linux and OS X and those type of Unix operating systems. They require the shebang line we talked about last week. That's the very first line in a program in the top left corner that defines the interpreter for the code. Now, Windows ignores that. Shock of shocks. Windows does something different than everybody else. But, and big but here, it is the best practice. It's what we need to do in this class. We will even put a shebang in our Windows coding, and that will help us understand how the writer of the code intended the code to be run. And so we can see that. So here is some examples of what we were talking about as far as indentation, continuation, and the shebang. Those are our first three things today. Up here at the top, on the left-hand top corner, you'll see the pound sign, exclamation point, and a slash, a right-leaning slash. Those three characters are the indicator to the interpreter that what follows without any space is going to be the path, the absolute path to the interpreter for the code. So I can tell by the /user/bin/env for environment that this is a Windows shebang and the environment is Python 3. So I know right off the bat, and the interpreter knows, everybody knows that this code was written for Python 3 on a Windows computer. Next thing here is we are initializing some numeric variables so that everything starts at 0. So this is just a good practice as well. We could get away with not doing this, but at the end of the day, this is the best way to do it. And then we have a while loop here that will allow us to run a loop or loop through this code as we are developing a test average program here. So while the test underscore score, that's the underscore notation there, test underscore score, that's hard to say, is equal to, or not equal to, excuse me, not equal to the exclamation point and equal sign is inverse. So not equal to 999. And notice the colon, that is very important in the structure of the command in Python. Then when this loop starts, the test score is going to include an integer that we are collecting from the user using the input. So this is a chained function here. We have the integer function with the input function in the middle. So let's work from the inside out. The input function here is asking the question for the user, enter test score, colon, space. That is a string right there. That colon doesn't do anything. Nothing does anything there other than just a string that appears on the screen. And then this integer function is going to change it to a whole number. Then we can go through our if statement here. If that test underscore score is greater than or equal to 0 and a compound expression here, test underscore score is less than or equal to 100, then the score total is going to be increased by the test score. This is the compound expression we were talking about, the compound operator. And so it just takes the number on the left and adds the number on the right to it, all in one easy to read thing. And we're also going to run the counter up by 1. We're going to add 1 to the counter here using the compound operator as well. Now we know that the counter is going to be 1 and the test score is going to be whatever our user entered. So we can figure out the average by, and once again, we've got a math equation inside the round function. So function is going to round this off for us. So the total score that we are putting together here, right on this line, is going to be divided by the counter that comes from this line. And that results in the average score, average underscore score. And then we print out a nice output here that, and we're using string functions here to change a number to a string. We're going to get into this in just a minute. so that these lines of text make some sense. You cannot put a integer or a float inside a string. You have to convert that integer or float to a string to include it in a string. Okay. And that's basically what's going on there. So we see examples of just about everything that we talked about earlier. Now, I said something to you about a little dent is not going to be enough. So this is a one space indent here between these two lines of code. And that's going to throw an error. This really should not be indented because that's a whole new statement. These are two separate functions. So that should be left justified. And this is already left justified. So we got a little bit of a typo there that would throw an error message. So I really should probably move this slide earlier in my stack, but I appreciate you guys sticking with me because now we're back to the implicit and explicit continuation. These two lines, these two print functions, the code is exactly the same except where we broke the line in our code, okay? And so the difference is right here. There's the backslash for the explicit line break, and there is no backslash here. But we waited until we got past the first parens, so that's one rule. And we also broke on the left side of the plus operator. That's the second rule. So we followed two rules in one. We only had to do one or the other. We did both of those. So this will work perfectly well with the interpreter. This will work perfectly well also, but now we did three things to accomplish it, and that's just kind of overkill. So that's not really very efficient programming. So at the end of the day, our coding rules are Python relies on proper indentation. You need to be about 4 spaces. And we have to use implicit or explicit continuation when we actually, we truncate is the correct word, truncate our lines of code. We break those long lines into shorter lines so we can see them on the screen when we're in our interactive shell. So we should be using implicit continuation. Marking comments is pretty easy. To mark comments, we just use the pound sign, and the pound sign can be used 2 different ways, which makes it pretty simple to do. And so if we put the pound sign all the way on the left margin, that is considered a block comment. So anything that's to the right of the pound sign will not go through the compiler. It's just going to be a comment. It's just going to be there to document our code. And so if we have 3 lines in our block, we have to put a pound sign at the left of each of those 3 lines. The inline comment is a little different. Say you're writing code and you've got a really great command in there that you've entered, and you want to talk about it. You want to document what's going on there. So after the code, a space or 2 is normally entered, and then a pound sign, and then whatever your comment is for that inline comment. We'll see an example here in just a second. Another feature of comments, and this is very helpful, as you're working with your code, you're testing your code, it may be that you just want to turn some code off. I don't want to delete it, but I want to turn it off so I can do something else. And maybe the compiler is not compiling and you want to comment out the code that's causing the problem and go ahead and compile without it. And that's possible. All you have to do is on the left-hand side of the offending line that you want to comment out, just put a pound sign there. And this is very consistent in Unix. We do this in configuration files. We do it in other programming languages, and we do it in Python. So it's pretty simple to do. There's a way to do it with the format menu in idle. I've never done that. So, I mean, to me, it's no big deal just to put pound signs to the left in our code when we are writing it up. I guess that comes from learning to code in an editor rather than an IDE. That's kind of my background. So right off the bat here, you see 2 examples of comments, block comments. These block comments have the pound sign all the way on the left. All of these are considered block comments. And then these are inline comments here because we got a line of code here. And then we want an inline comment that tells folks what we're doing. So if you're going to be a really good programmer and do well in this class and other programming classes, you have to learn how to comment your code so somebody can read it. And when I say read it, if I don't understand what you're trying to do and you use shortcuts or some tools that I'm not familiar with, it just makes no sense to me. But the documentation will help me understand. And uh, comments are serious business. You really should enter as many useful comments as you can. Now here we're commenting out code. We're just basically turning off these lines of code, and so that's how you would use it, kind of like an on-off switch, which is very helpful. One thing I will tell you about comments, I read this years ago, and I've seen it repeated many times. Documenting your code, putting comments in your code is like writing yourself love letters. So if you want to get love letters in the future, when you look at a project you wrote years ago, you're going to love those comments. You want those comments there so you can see what you did and figure out what you were trying to do and move forward. So try to do that. It's really a good idea. So we talked about disabling the code. That works good. Let's move on to functions now. Functions, by definition, basically are a group of statements that perform a task. Reusable code. It is an efficient way to program. The less we have to write, the better. The less work that the compiler has to do, the better. So, as we have said many times, Python comes with oodles and oodles, bazillions of built-in functions. And we're going to learn how to access those many, many libraries of functions as we go through this course. We'll learn how to write our own functions in unit number 4 coming up in just a couple of weeks. So understand that functions are tools, okay? They have syntax, and we need to follow the syntax. And the syntax on the functions are going to be different based on who wrote the function, and we're going to learn that we have to follow the rules of the function. So the syntax is pretty basic. We have a function name and then 2 parens, left and right parens, and inside those parens, we may or may not have arguments. It is possible to have functions that do not require arguments, but 9 times out of 10, there's going to be 1 or more arguments. And those arguments normally are comma separated or space separated. So you need to understand how they work when you are programming so that you can do it right. Now, once the function has been defined, DEF defined, uh, then you can call that function. And the syntax we just looked at here really is calling the function. That's the key word. We're not defining the function, we're calling the function. Just write the function name and the 2 parens, left and right parens, and if required, put the correct arguments in between those parentheses. You may have to worry about the order in which those arguments are entered, or you'll have to worry about entering the name of those arguments, depending on how the function's written. Personally, I like to name named arguments and functions because then we don't have to worry about the order. But if they are not named, they have to be in the right order that the function creator, however the function was defined, requires them to be entered. And that's why documentation is important. You would enter that in the documentation so people would know. So you're going to see a bunch of functions today and in all of our future classes. We're going to start off with our go-to number 1 function is the print function. All print does is put information on the screen, which is important because everything we're doing in our programs is processing data and putting the results on the screen. And so we're going to run a ton of print functions in this class. So it is possible, and we'll see it right from the beginning here, to run the print function with nothing between the parens, and that creates a blank line. And so for spacing, we would have an empty print function for a blank line. But more times than not, we're going to have data in the argument, and that's all that's required in the argument is data. So throughout our book, you're going to see these blue boxes that tell us about the functions that we're learning and how to use them. And as we go, the more you can retain that, the better. It'll make you a better programmer. So our first function is the print function. You can see the syntax calls for data between the parentheses, and the description says prints the data argument to the console followed by a new line character. Now, followed by a new line character is important to us because 99 out of 100 times that is fine. Once that print function runs, we want a new line, but sometimes we will not want that. So we're going to see how to change that. If the call does not include a data argument, the function prints a blank line to the console. So we have three print functions in our little example here. And notice the quotation marks, which means that this is a literal string. There's nothing fancy going on here. It's just words and spaces and an exclamation point. And so this is a string. If we did not have those quotation marks, would have a problem is what we would have. So the quotation marks are important for strings. Then in the next function, we have an empty print function. So that's a blank line. And then we have just another string here, which is basically the same process as the first line. But when we run this and compile it, you see we have a blank line in the middle, and we can see the two prints that we asked for, the data we asked to be printed. So that is probably the simplest of all the functions we're going to learn. At this point, we start increasing our knowledge and increasing our understanding of data types, and that changes things when it comes to functions. So there are several data types in the world. We're going to be concerned about strings, integers, and floats right now, because those are the ones we're going to run the most in Python class. We've already talked about a string. Now understand this. A string is not just alpha characters. It can also be numeric. Numbers can be a string, okay? And most of the time, and I'm kind of going out on a limb here, most of the time when we process numbers, the result is going to be changed to a string before we print it, because normally it's going to be printed with some alpha code. So we will want to change it to a string. You'll see what I'm talking about here in just a minute. So the integer is a whole number. Realize an integer has no fraction, no remainder, okay? So it is not a decimal point. That is a float. And both an integer and a float can be positive and negative. If you want to have a negative integer, you precede it with a hyphen. Same thing with a float, and a hyphen before the decimal point. So super easy. One other thing, a string does not have to have double quotation marks. It could have single quotes. And that is significant. We're not really talking about it in this unit, but typically single quotes trump double quotes. So we'll see if that is the way this thing works out. But when you have one quote, you got to have a second quote. That is a fact. You cannot leave a quote hanging out there all by itself. So if you have a left quotation mark, you got to have a right quotation mark. Single quote, double quote, double quote. You have to have pairs. Now, normally we assign data types to variables in our program, and we do that by the punctuation. There's no other magic to it, okay? So we have some kind of creative, informative name for our variable, first underscore name, quantity one, whatever it is. We have an equal sign, and then we have the value for that variable. If it is a string, it is going to be enclosed in either single or double quotes, like CPT 168 equals quotation mark, my favorite class, quotation mark. Now, I can't make it any simpler than that. Another way of speaking about this or reading about this or speaking out loud, this is called assigning a value. It is an assignment. So when we assign a variable, if you see that in the chapter, so well, you need to assign this variable, yada, 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 that means variable name equals something. The equal sign is the assignment operator. Okay, if you want to get real specific. So I don't know that that's explained in this chapter. It kind of sneaks up to you. At least it did last semester. It snuck up on a lot of people. So go ahead and get that out in the open. Slide 23 gives us some examples of establishing, initializing the data value and the data type in some variables. First name equals Mike, and you can see it's a string because we have the quotation marks. Quantity 1 and quantity 2 are integers because we have an integer to the right of the quotation mark, the assignment operator. And list underscore price is a float because we have a decimal point. So 19.99 automatically makes it a float. And we're soon to learn that floats are not always our friends. That does present some problems. In the second example, it looks exactly like we're doing the same thing in the first example here. What we're doing in the first set, we are initializing the values and data types. In the second one, we're assigning new data to the variables. It looks exactly the same because we do it the same way. We're just changing the value. That's all it is. Okay. And also remember when you call these variables, when you want to use these variables, the case matters. In the bottom example there, we used a capital Q on quantity 2 instead of a lowercase q, and we got an error message because uppercase Q was not defined. That is a very common problem for rookie programmers. So make sure you use upper and lowercase properly and be consistent. It's an easy thing to make a mistake on, and you'll see, I think all the error messages in this whole chapter deal with the wrong case. There are 52 letters in our Python alphabet, 26 lowercase and 26 uppercase. Just remember that. When we put a string inside quotation marks, either single or double, we're creating a string literal. It's called a string literal. It's literally a string. If we do something without quotation marks, it's going to be called a numeric literal. So you're going to have error messages if you try to make alpha characters a numeric literal. So don't do that. But just realize the quotation marks make it a string literal, and without the quotation marks makes it a numeric literal or a float if you have a decimal point in it. So let's get into the naming conventions for our variables. You can begin a variable name with a letter or an underscore, nothing else. No numbers, no fancy characters, just an underscore or a letter. Could be an uppercase letter or lowercase letter, that's okay, but a letter or an underscore. That's a very simple thing, and people screw it up all the time. So I'm stressing that. A variable name cannot have any spaces in it, no punctuation, no special characters. The only thing you can use is an underscore. So that's why underscore notation is an option for us, and we can use that to separate name words in the name of the variable. The underscore takes the place of the space. Whereas in camel case, as we will see, we just use an uppercase letter, and it's a little bit easier. So a variable name cannot begin with a number. I said that. And a variable name cannot be the same name as a keyword in Python. Now, most keywords in Python are either statement commands, some type of control word, or a name of a function. So we have a little, went too fast, a little list of Python keywords here that we have to stay away from. We cannot use these as variable names. The list is not terribly long here, but it gets more complex really because when you have a big program with a lot of custom functions in it, things like that, then you will have to deal with those as well. They become keywords. So you just cannot reuse keywords as variable names. Some best practices. Variable names should be meaningful names. They should be something that is descriptive, something that someone reading your code will be totally impressed and understand exactly what you're doing. Avoid abbreviations. We all tend to do it, but it's not a good idea. The example in the book, MON_INV. So I know exactly what that is. That is Monday's invoice. Nope, that's not what it is. It's supposed to be monthly investment. Ergo, my problem. That abbreviation is not clear. So be careful with abbreviations. That is a big problem. Spell out the words uh, for your variable names, especially early on here. The better you get at programming, you'll also get better at abbreviations. If you do use abbreviations, avoid abbreviations that are specific to one industry or field of study. So MPG, pretty good. Most people will know that MPG is miles per gallon. That's okay. But how about CPM? Cost per million, customer perimeter measurement. I mean, I'm just making stuff up. I don't know what CPM is. It could be lots of things. So what does CPM stand for? I have no clue. That is not a meaningful name for a variable. So just realize, yeah, you want your code to run as a program, but also you want your code readable for code reviews, for assignments with your instructors, for things like that. Okay. Just be aware that your code is like an essay in a lot of ways. You have to follow some rules for clean code, and the name of your variables is certainly one of those rules. I think we pretty well explained the difference between underscore notation and camel case, but for those of you that just dialed in, here's the best example. These are two variable names, both of them work. There's an underscore here separating variable from name in underscore notation. I prefer camel case. So it starts off with the lowercase letter, and then when a new word comes along, it is uppercase. So variable name, and if you had three words in the variable, like variable, uppercase N, name, uppercase Jones, or whatever. I don't know, whatever the third word might be. So just realize you don't have those underscores getting in the way. I don't know. To me, that is cleaner. So I think this is interesting. In the textbook, our writers use underscore notation in sections 1 and 2, and that is 13 of our 14 chapters that we're going to study this semester. So we're going to see a lot of underscore notation. Then in sections 3 and 4, where everything is object oriented, then he changes to camel case because camel case is normally used in object oriented programming. We will get to object oriented programming well before chapter 14, but you'll see that from 14 on to the end of the book, it's going to be all camel case. And so immediately he sets a rule here that he broke. The best thing is to pick a naming convention and be consistent with it. The worst thing you can do, if you look at one of the early programs I wrote, I mixed the naming conventions up because I wrote that program over a long period of time. There were gaps in it, and I was inconsistent. And man, I learned that lesson the hard way. When you start a project, stick with the naming convention. Do not get hinky on that. It is a good way to look like a rookie when you're mixing up your uh, your syntax for your naming convention. Okay, I think we hit on all of this stuff. Make sure you do not use any names of any built-in functions. All right, let's move on to math. Are we doing good on time here? We're at 10:25. Let me do some math in my head. We're real good. I don't want to have you longer than an hour and a half today if I can help it. I know you guys want to get in front of your TV and watch the inauguration. Um, so the arithmetic operators, these are just as universal and common as they can be. Plus for addition, a hyphen or a minus sign for subtraction, an asterisk for multiplication, and a right-leaning slash for division. We're cool on all that. Everybody will do great with those four. We've been doing those on calculators forever. How about slash slash? Two right-leaning slashes. That is an integer division. The result will be a whole number with no remainder. It just drops the remainder. So that is different than a single slash, which there will be a remainder. That means the result of a single slash division is going to be a floating point number, where a slash slash, the result's going to be an integer data type. That takes us to another operator, which is the percent sign, which is also called the modulo or the remainder operator in Python. I'll call it the remainder operator. I've also seen it called modulus. Modulo is what this book has. And all that's going to give you as your result is the remainder as an integer. Okay. That can be helpful depending on what you're trying to do. We'll see an example here in just a second. And then asterisk, asterisk, two asterisks. It doesn't mean multiply twice. That's not exactly what it means. It is exponential. It means to raise the left operand, the number to the left, to the power of the operand on the right. And so you've probably studied exponentials in other math classes and things like that. This is just a way to have Python do it for you. So in our examples here on slide 32, 5 plus 4 equals 9. That is all in integers. 25 divided by a single slash there by 4 is going to result in a float, 6.25. Whereas 25 slash slash 4 is going to result in an integer, which will be 6. And the dot 25 is dropped. If you want to see the remainder as a whole number, and we don't use remainder operators very much, not at least I don't. 25% 4, and all you're going to get is the remainder, which the closest thing we can come up to is 1. There's 1 left over there. So the exponential 3 asterisk asterisk 2 means raise 3 to the power of 2. So that would be like 3 times 3, which equals 9. So those are how the operators work. The next problem is the order of operation or order of persistence, which comes first. And surprisingly to me, the most complicated come first and the easiest are at the end, okay? I was kind of thinking maybe the easiest would be first, get them out of the way. But that's not the way it works. To me, the most complicated is exponential. That's first, okay? And then left to right here on this table on slide 33, we have multiplication, division, integer division, and remainder in that order. And then finally at the line 3 there, addition and then subtraction. So that is the order: exponential, multiplication, division, integer division, then the remainder, then addition, and then subtraction. But we can change it. We can change the order of persistence by using the parents, okay? And so if you want something done earlier rather than later, enclose that part of the calculation of the formula of the algorithm in a pair of parens. So without parens, 3 plus 4 times 5, we know that I want to make sure I say this right. Looking at the order of persistence here, the first thing that's going to happen is the multiplication. So 4 times 5 is going to be 20, and then we're going to add 3. That's basically doing that calculation backwards. That's why I stumbled. So we could do it a little bit cleaner by using parentheses and say, okay, first thing I want you to do is 3 plus 4 is 7. Then I want you to multiply. And remember, multiplication has a higher persistence than addition does. So 3 plus 4 is 7 times 5 is 35. All right, moving along here today. If you have any questions, let me know. I can't see much here other than the slides and the chat. Let's see here. I did get a question right in the middle of this. Oh, actually, several questions. So I'm going to pause for a second and look at the chat. Are we going to need to include any specific comments in our programs going forward? Yes, lots of them. You need to document your code, period, paragraph. We're going to learn professional programming. And if I look at your code and there's not documentation in it, I certainly have the right to deduct points because of that. Does tab work as an indent? Yes, it does. And in where is it? In the if statement, do you have to indent the second line? Yes, because that's part of the statement. That is considered the block of code. Yes. What's the purpose of converting the numerical variables to strings for print statements? Can't you just use a comma with the variable name and get the same result? Absolutely not. The Python interpreter will throw a huge error when you do that. And we will see that in this unit, in this chapter. So we always want to, if you're going to combine, and we're getting ready to hit that right now, when you combine a number with a string in a print function, you're going to have to change that number to a string. They have to all be strings before the print function is going to work. All right, so good questions. Thank you for that. Let's go ahead and look at how to use arithmetic expressions in assignment statements. So we're just basically doing the last two things we talked about together, okay? We're initializing a subtotal to 200 here and a tax percent to 0.05. For those of you that are mathematically challenged, that is 5%. So 0.05 is 5%. And then we're going to calculate the tax amount. We're going to multiply the subtotal by the tax percent, and the answer is 10.0. That 0.0 is significant because we are multiplying an integer by a float, thereby the result's going to be a float. And then the grand total is going to be the subtotal plus the tax amount. Remember, the tax amount now is a float, so now the result of the integer and the float going together, that data type is going to be a float. And notice when there's nothing to the right of the decimal point, the float is 10. So formatting comes into play. Formatting comes into play for currency and all. We'll get into that later in the course. Initially, we'll go along with the default, but we want to make sure we make that look better when we write a real program. In the bottom example here, we're calculating the perimeter of a rectangle. That's all the four sides basically added together. And we're going to do it using addition and multiplication and parentheses to get our persistence in the right order. So the first thing that's going to happen is we're going to multiply a width, which is a float, 4.25 times 2, and add that to the length multiplied times 2. And so if you look at the inline notation comment there, the inline comment, 8.5 plus 17 gives us our perimeter of 25.5. So just remember, when we do our math, what's in the parentheses is going to be calculated first from left to right. We have two sets here, so it's going to be from left to right as it goes across doing the calculation. Now to those compound operators I mentioned earlier. I like these. You can find a lot of uses for compound operators. Just realize we're doing two things at one time. You can do it other ways. It just takes more code. So this makes your code more efficient. So let's read this. For instance, the plus equals operator is going to modify the value of the variable on the left of the operator by adding the value of the expression on the right of the value to the variable on the left. So it's basically taking whatever's on the right and adding it to what's on the left. Maybe that's not as academic, but that's what happens. And so when you use the compound operators, make sure the variable on the left exists and has a value to it, okay? Remember, we initialize those values at the beginning of the program. That's a good reason to do that, so your compound operators will work. So it's, like I said, it's not required, but it's a best practice to go ahead and initialize those at the first time those numeric literals come up in your code. You want to go ahead and initialize them. So there's 3 of these compound operators, and the subtraction one, minus equals, does exactly what you would think. It subtracts rather than adds the value on the right from the value on the left, and multiply, as you would expect, will multiply the value on the left by the whatever's on the right. And we'll see examples as we go along. So a couple of ways to deal with incrementing a number, okay? Now, the old school way is to add the number to itself. The new school way is to use a compound operator. So in our first example here, we are initializing the counter to 0, okay? And then the old school way, the counter plus 1 increases the value of counter by 1, okay? That's not anything too earth-shattering. Then in the second example, we're using the compound operator. Well, at this point, counter is already 1, so we're adding another 1 to it, and that's why it becomes 2. So that's a good example of how a compound operator works. It's just less code, it works faster. The code that adds 2 numbers to a variable. This is using the compound operator twice. So we initialize the value to 0. We add 70 to that 0. Okay, this is what I was talking about. Because we initialized the variable here, the compound operator works. We add 70 to 0 and we get 70, and we do it again here with 80. So we're adding 80 to 70 and we come up with 150. And just some more examples. Here we have 1,000 and we're going to add 100 to it. Here we have 10, we're going to subtract 1. Here we have 100 and we want to multiply it times 0.8. So that's the only example we've had of the multiplication compound operator. So this is what we're multiplying by, and this is number that we are multiplying. And at the same time, that variable is going to change with that result. So now we move to a problem with float values. And this is a nuisance, an annoyance, something that is going to cause you some heartburn, okay? And we might as well get it out on the table first here early on in the course. And that is when you use float values in mathematical calculations, the result will not always be correct, okay? It will not be exact. And the problem is the float goes crazy. It goes all the way out to as far as it can go. And so in our example here at the bottom of this slide, we have initialized a subtotal at 74.95, and then we are going to multiply that subtotal times 0.1, okay, what's that, 1/10, okay? So 1/10 of this ought to be $7.49. Or if we want to carry it 3 places, $7.49.5, okay? But look what the floating point does for us. It goes all these many decimal places and has a 1 out here. And if you do that too many times, you're going to make your users unhappy. So we need to take into consideration that that's going to be very common in float values in a calculation. So you're thinking, okay, Bo, now you're telling us the bad news. What about the good news? The good news is we just run it through a round function, and that takes care of it. Rounding it will take care of it, and we'll see that. We'll actually see some other ways to deal with it later in the course, but right now we'll just round that result, and we'll see some examples of that in this chapter. Okay, so a review here from Unit 1, because we've got to be all about idle here. And since this is review, I'm just going to hit some high spots here. Remember, when you use the interactive shell and idle and you press the enter key, idle will process or will interpret the command that you entered, whatever the line of code is that you entered at the prompt. If you are initializing a variable and you're using that variable in a calculation and you want to see what's in that variable at any point in time, just enter the variable name and press enter. That's it, just the variable name, press enter, and you'll see what's in the variable. So those are some simple things that you can do. We have some examples in the chapter. So starting up at the top here, 25, and then we have 2 right-leaning slashes, 4. So this is an integer division. And so the answer is going to be 6. 4 will go into 25 6 times, and to heck with the remainder. We don't care. If we used 1 slash, there's our remainder dot 25. That becomes a float. This is an integer. 25 divided by 3 is going to result in a float. Look at all those decimal places. We'll deal with that later, but right now that's the way it will come out. Let's initialize counter to 0, and we will add 1 to counter. And we say, okay, well, what is the value of counter now? Just enter counter, press the enter key, and we see the value is 1. Counter, use the compound operator 1. What's in counter now? It is now 2. Subtotal equals $250. Our tax percent is 0.04, which is 4%. Our tax is going to be the subtotal times the tax percent. So how much tax did we charge? $10. Okay, so the total is going to be subtotal plus the tax. What's the total? Is 260. So let's see what happens when we subtract the tax. So total equals total minus uppercase TAX, red stuff here. We got a problem. There's no sound effects. I just threw that in for fun. Is that uppercase T on tax is a big problem. So that is what we want to avoid. We want to remember that we have to be cognizant of case all the time. So now we're going to start dealing with the question that David asked about the numeric values inside a string, okay? And so we're going to see some examples, use single and double quotes to create a string literal. We'll see an empty string by coding a set of quotation marks together. And then we're going to assign some new values to those strings. And then we're going to see what happens when we incorporate numeric values into it. So the string function is very simple, very, very simple. Whatever the argument is in the function, the data inside that function will be changed from whatever it is, whether it's a float or an integer, will be changed to a string, okay? And so there are some simple ways to initialize strings, to set strings or assign strings with double quotations, single quotes, name equals quotation, quotations, an empty string. We can have 2 words in a string, and none of that should shock you. We've been doing that. Here's where it starts getting interesting. When we add concatenation, whew, that's a hard one to say, concatenate. Basically, when we join bits of data together into a string, okay, and this is cool. We use the plus sign operator for this purpose, and we can concatenate with a plus. We can do more than one thing with a plus sign, and this is one of the neat things we can do is concatenate. So, for example, if we wanted to take a first name and a last name and combine it together to get a whole name, that's what this example here at the bottom does. We want the name to be the last name plus a comma and a space. That is a little string right there, a little bit of data. So that's 2 characters, a comma and a space. plus the first name, okay, and the output would be Bob, comma, Smith. Excuse me, Smith, comma, Bob. Sorry, Smith, comma, Bob, my father-in-law's name. Now, when we put a number in it, it changes a little bit because you cannot join a string and a number together. So we can use the string function to change that number to a string, and the concatenation, the join will work. So look at this example. We have a string here, Bob Smith, okay, with a space in there, and his age is 40. We're going to create a variable here named message, and we'll start with the name, Bob Smith, plus space, that is a space right there, is, and another space. So there's a bunch of going on here in that little bit of a string. And now we're going to convert age to a string. That's how easy it is. str string inside the parens, the variable age, and then plus, and then we're going to add another little bit at the end here, a space, year, space, old, period. And then when we, the output of that is going to be Bob Smith is 40 years old, period. So what happens if you don't use the string function? This is what you get, a big old error message, and it's going to be a type error. And that is fairly easy to diagnose when you see it. When you see type error, that's a data type error. Can't convert integer object to a string implicitly. That means the interpreter is unhappy and you have to go in and fix it. So that is what's going on there. Next, we're going to look at escape characters. Does that answer your question, David? Let me make sure David's okay, if he's online still. I get why you have to convert a number variable to a string if you're adding it to another string, but I'm talking about the print function specifically. No, in the print function, you do not have to make it a string. You can print a number. I misunderstood your question. But if you are going to concatenate, you have to, okay? My bad. I didn't get the print function part. Okay. So now we're going to look at escape sequences. And this is when we want a special character in the string to be a literal and not a special character. Another way to say that is there are certain characters that the interpreter will do something. It's going to have some meaning to the interpreter that is different from the literal character. Okay. And this is very Unix, very Linux. This happens all the time. So we will have to use the escape sequence to change a special character to a literal. Okay. Now there's certain things, there are certain escape sequences do certain things. One that you're going to see a lot is \n. So escape sequence always starts with a backslash. So \n is a new line, \t is a tab, \r is a return. Okay. So those have a special job to do. And we'll make new lines. We'll put tabs in. You'll see that all over the place. Now, what if you want a quotation mark as a literal rather than as marking a string? Remember, we use quotation marks to mark strings or set data type. So we have to put a backslash in front of a double quote or single quote for that purpose. And, to carry it one step further to the ridiculous, what if we want a backslash just to be a backslash and not anything special? So we would enter two backslashes. We would actually have to do that. You have to do that in URLs, as we'll see right here. So the \n escape sequence is right here in this print statement. Okay, so that breaks that line into two lines. We can tab. This is interesting. Notice there are two tabs between title and Python programming. We have a line break here, and then we have quantity, and then one tab. And you're thinking, well, Bo, why is there one tab in one place and two tabs in the other? And that's because quantity is a bigger word than title. So sometimes you have to experiment to see how things line up. And when we start doing our first programs, one of the things I'm going to be looking for is making sure you have nice, pretty output and all the columns line up. So watch those tabs, get the tabs right. Here's an example of escaping backslashes in a URL, an URL, and that's a good example. So to get the output of the print function to be an URL that makes some sense, like we have here, we have to escape those backslashes. So these escape sequences are required by the compiler, okay? Many times we'll have quotations within a string. I think we covered all that. Okay. And just some more examples of escape characters, backslashes, escaping double quotes and single quotes so that the output string behaves itself and does what we want it to do. So pretty simple concept. Just make sure you're consistent with it. Here's some examples in the interactive shell in Python. We see the concatenation on the third line here for full name. Notice in the fourth line, we just enter full underscore name to see what the value of full name is. And then I don't know what line this is, but right here is the output of messages once we get things right. So full name is correct at this point. It's Smith, comma space Joel. We set the value of age to 40, and then our message is going to equal first name plus, and then a little bit of a string here, space is space. Then we have our string with the value of age here plus another bit of data, space year, space old, period. And that's the end of it. Uh-oh, we got a syntax error. What happened? We forgot the concatenation there. We forgot the plus operator and the join. So that is a problem. Once we put that plus sign in there, we can run message and you can see the output's exactly what we expect. So if we just try to use the concatenation with age, we get the error. This is exactly what we were talking about. Trying to convert an integer to a string implicitly does not happen. So here's the correct way to do it. All right. I think we've repeated ourselves enough on that. So test a statement in the shell. Make sure your names are right. Make sure that your variables are collecting the data you expect them to. So expand those variables in your interactive shell to make sure your code is right. Just remember that those variables are staying in memory while you're in the interactive shell of your IDE. And so you don't have a problem losing them, but just make sure you save your source code to a PY file once you finished coding, or if you want to stop for a while and come back to it later before you exit the IDE, or you're going to lose all that. You're going to lose your code. So it's just like any other editor, you have to save your work. Print functions, I think we have dealt with this except for one thing, and that is a named argument. Now, in some functions, you will see that there is a variable equals something. There's a named argument. It's basically a variable inside the function. And to me, that is the best way to handle a function when we get into creating our own functions. So we'll see that sometimes. And this is not really a good example of that, but you can see how we have incorporated strings inside of inside the print function. This is kind of back to what David was talking about, because in this we have a float here in this print function. We have a string and a float together in a print function. This is not concatenation. This is just two pieces of data that we want to print. And so notice the string is inside quotation marks and the float is not. This is interesting. Remember, inside the print function, we can separate our data amounts with a comma or space. And so we put commas in here and the output has no space. So the default separator can be changed. We can change the separator and we can also change the end. That is coming up here in just a second, teasing the next slide. So this example is a print function that has 4 arguments in it. We have a string, then we have the output of a variable. We have a new line. We have a string. The new line's in the string. Notice that it's inside the string. And then we have a number, okay? In this print function receives one string as an argument. So this is another way to do it. You don't have to do it this way. Notice this worked or this worked, but we're using the plus operator here and the plus operator here. And that's why it requires converting those 2 values, those 2 numbers to strings. So this works and this works. It all has to do with how we are handling data types and the operators here. Okay. So changing the separator and changing the end. So notice that in the syntax for the print function, these are enclosed in brackets because they are just there. So the default separator is a space, okay? And the default end is a new line. But we can change the end or the separator to something else so that we can do more with our print statement. So in this example, we change the separator to a space, a vertical line, and a space. There's 3 things inside this, this string here that we want to have at the end of our print statement. And so we want to print 1, 2, 3, 4. So those are 3 numbers. And we're going to separate them with a space, a vertical line, a space, instead of a single space. And so that's how we got this output. We're changing the end to, in this case, another string of 3 exclamation points. Notice the commas go away because that's an option for us to use commas. We don't have to. And we get 1, 2, 3, 4. We have a default space between them, and then our 3 exclamation points. My suggestion when you get to an exercise where you are going to change the separator or the end of a print function, test it. You can do that inside the interactive shell. Test it, make sure you get it right. Another function, this is a cool one. I like this function because this is where you start feeling like a programmer. To me, you start feeling like a real programmer when you ask a user to tell me something. We're starting a dialogue with the user of our program. And so the input function is important. Now, realize that our users just, I hate to say this, but users are dumb as a brick. So your users probably are going to screw something up. We have to be careful on data type and syntax when we start accepting data from our users. And that's going to be our problem all the way through the whole course, okay? But in the early going here, we're going to deal with the data type problem with the input statement. We're going to start embedding inputs inside a string or inside a float or whatever function to get the data type the way we want it to be. So the input function from the beginning can do a couple of things. First off, it can be empty. The input will just be empty, and what it will do is stop the operation of your program, and it waits for your user to do something, even if that something is as simple as hit the enter key. But without anything between the parens as the argument in the input function, there's nothing on the screen to tell the user what to do. Just realize that. Then if you put something inside the parens, it will be a prompt. It will be a prompt to the user. And normally it's a string, so you're going to put it in inside quotation marks. And we have a bunch of examples of that. So the definition of the input function in the book pauses the program. It will stop. It'll wait for the user to enter data at the console. Could just be an enter, but the user has to hit enter. That's required. So when the user presses enter, this function returns the data entered by the username as a string by default. Defaults to a string value. If the call includes a prompt argument, this function prints that prompt to the console before pausing to wait for the user to enter data. That's what I said. So textbook versus Bo's mumbling version of the definition. So right off the bat, we're going to just collect a string from a guy, okay? So first name equals input function, and we have something inside the parens. It is a string. We've got it in quotation marks. Enter your first name, colon, space. There's a space there, and in the string, okay? Then print hello. That is a bit of a string here. Hello, comma, space. That's in quotation marks. Plus operator, first name's already a string, don't have to do anything. Plus, and then we have another one character piece of data, a string that is an exclamation point. There you go. He enters Mike. Hello, Mike. Simple little program. Another way to do this is to break it into two lines. Use a print function and an input function. This is only a good example of an empty input function. To me, it's a pain. So you may like this, I don't know. But here we're asking for the first name to be input. We have to give the user some kind of guidance here, because when the first name equals input, when that input function runs, it's just going to be nothing on the screen. All that's going to happen is the program's going to stop. So Mike will start typing his name. Notice it is left justified here on a new line. And then we can have the same line of code here to output hello, Mike. Here's another example of collecting numbers, okay? So we're going to initialize score total to 0 and then use the input function to collect or request numbers. These are going to be whole integers to be added to the score. And then we will come up with the score total with this particular, actually this is where the collector works. This is just going to change the value of score. And then the next line of code is going to take score and add it to score total. But this is going to cause an error because score is a string, okay? Remember, the default is a string here, so we're going to have a problem. We can fix that by changing, by adding a function in there. So that takes us, because we wanted to see that error message, or the cause of an error message, that takes us to the integer. And so on that request for that score, we want to make sure, because remember, input by default, input is only going to collect a string, okay? Maybe I didn't make that clear here. We're collecting score here, and right in this line of code, that is going to be a string. So score is a string. When we try to add a string to an integer, we get an error. So inside this input, actually put this input inside an integer function will solve our problem. So that takes us to integers and floats. We just need to convert that. And this is what I was talking about, dumb as bricks. We want to convert the value that our user enters at the console to the right data type so we can go about our business. And we don't want to have all those exceptions. So we'll see how to fix that right now. So integer is going to be convert the data to an integer, float to a float. And last but not least, we haven't talked about this one. I mean, these two are easy to understand, but round is a really neat function here. Round, if you don't put anything in between the parentheses, my phone's ringing here, distracting me. It will round to a whole number, okay? So typically when we're rounding, we probably want to round to a number of digits. So we have an option here to define the number of digits here. And you'll see that a bunch in when we see round working. So here's an example where we're going to have a problem. X is a number and Y is a string, and we try to add them together, and you can't do that. So a way to fix this, we have the same exact initialization of those variables, but here we're changing Y to an integer with that function so that Z will be a number, X is a number, and now Y is a number. It all will work. We got to stay in our data type. So there are a couple of ways that we could do this. One way to do this is with two functions. We collect a quantity as a string, and then we run a second line of code here that changes quantity to a number. But the preferred way is to chain. This is chaining the functions. So we just go ahead. We know quantity's got to be an integer, and we know that we're collecting a string from our user. So we'll have an integer with an input inside the integer to collect the quantity. Okay. And that is so cool. That makes it so easy. One line of code, boom, there it goes. Let's see here. Got some stuff happening over here on the chat. It's more typing to do the second way. Yeah, the more typing you do, to me, the more typing you do, the more chance you have of making a mistake. And Christopher says, what would happen if you convert a letter or a string to an integer or a float? For example, trying to convert the letter A to an integer, you're going to get a data type error eventually. So try it. My advice to all of you is do not be scared of the interactive shell, the idle IDE. Just open it up. And when your mind goes there and you have this question, just type it in and see what happens. Because that is your closest way to see what the interpreter will do. And the sooner you learn these quirks, these things that you've got to take care of, the better your program is going to be. So it's going to be an issue if you make an alpha character a integer. I think the interpreter is going to be smart enough to throw an error at that point. Chaining functions is a good idea. Okay, so this is real common. This happens all the time. And this is where we will use the round function. So we have an integer of 150 and a float of 5.875 here. Miles driven, gallons used. And we're calculating MPG. And everybody knows that means miles per gallon. So miles driven divided by gallons used. And our result is going to be a long decimal number, okay? But this is how you use the round function. This solves the problem. We just run MPG through the round function, MPG, comma, to 2 digits. Remember that number, that second argument there is the number of digits. And then our output's going to make more sense, 25.53. Now, once again, we could do our math inside a round function and have less code, okay? So the round function, inside it, we want miles driven divided by gallons used. And oh, by the way, comma, I want 2 digits. So this is the more efficient way to code that. And we're all about being efficient in here. All right, so we're almost done. We're pretty much on time. And we might be a little late. Let's take a quick look at 2 programs because you're going to deal with these programs in labs. And these are illustrative programs that kind of show you what we've been dealing with in this chapter. And this is very typical of how this book is set up. We'll have example programs, illustrative programs at the end of each chapter that you guys can use and learn from. So we're going to change some functions and we're going to try very hard to have as few exceptions as possible. No exceptions is what we want. So here's the output that we're looking for. We have a title, a blank line. We have 2 input prompts. We're going to collect miles driven and gallons used. And then we're going to do some math and come up with the miles per gallon. And because we're polite around here, we'll say bye. Okay, very simple little program. And you'll see a lot of programs in this book are kind of set up the same way. First off, we have our shebang line. Then we have a comment here. We're going to display a title, print function title, blank line, get input from user is a comment. Miles driven is going to equal a float. and we want to run this into an input. Okay, float with an input inside. We're chaining together. Our input's going to be enter miles driven with a couple of tabs at the end. And notice all that's in quotation marks. Be sure and account for all of your parens. Okay, make sure you don't leave off a parens. That'll throw an error. Gallons used, float once again, input, gallons used. And in this case, we only need one tab and we have our two quotation marks. Next up, we want to calculate and round miles per gallon. So we've seen this in our examples. Then we want to display the result, blank line. Here's our result, miles per gallon. And we have a couple of tabs here, and we are going to convert because we are using the plus operator here. We have to convert miles per gallon to a string, blank line, by. Okay, that is our first example. I almost made it to the end of class without coughing. I am amazed. Let's take a look at the next program. Very simple program. This program we're going to build on through the course of our class or future units in our course, depending on how you want to say that. We have a very arbitrary program. You're going to enter 3 test scores, then you're going to average those 3 test scores and get a result. So this program has a very similar console output. We got a couple of things that we have not seen. We have an instruction. We want just another print function. We have a pretty line of code, kind of a highlight line here, bunch of dashes, and we have it again here. So that's another print function. Then we have 3 input functions here that are collect the scores. We're going to do some math for the total score and the average score, and we're going to say goodbye. Now, this style is Murex style. That is something that happens when you program. You start using the same look for your programs, okay? So here's our shebang line, our display at the top. There's our title, our blank line, our instruction line, and our dashes for prettiness. Then we get into collecting the data from our user, get our scores and accumulate the total. So we establish total score is 0. And then we have 3 identical, and notice that inline comment, I forgot that. We have 3 identical inputs here. We want these to be integers. Remember, inputs by default are strings. So we have to convert them to integers, just embed or chain the input into the integer function. Make sure you have all the syntax right. You got to have the 2 parens because we've got a parens there and a parens there. So this is just going to be, and notice the compound operators here. This is very efficient code because total score is growing, increasing by each of those scores we input. This is very neat code, very simple code. We could do this another way with bunches of lines. 10 lines of code would not surprise me. We're doing it very efficient here. So now we want to average these scores, and this is arbitrary. This is built for 3. We'll learn how to not be arbitrary later on, but total score divided by 3 will give us our average, but we need to do that math inside the round function. We're setting it to 3 decimal points, so we don't have that big, long floating point value. Then format and display the result, a pretty line, a label, and then we have our total score, break the line, a line break here, and we're using implicit continuation here. Average score equals the average score and a blank line and by. Okay. The only thing I might suggest is making sure those columns line up. There could be maybe a tab in there to make sure that happens. I don't know. So those are our 2 example programs. So moving along here, at the end of Unit 2, these are our terms. We had a bunch of them. So my suggestion is always to look at the unit terms at the end of each unit or each chapter in our book. This is going to be your way to check off and make sure you're learning how to talk. I'm doing my best to do the same thing. I don't always do it, but I want to do it as many times as I can. And then I want you to be sure and take a look at the summary. Now, yesterday, what's today? Wednesday, Monday, I went through the summary and I highlighted the words, the terms from the chapter that I think are significant. And so maybe studying the slide here will help you remember the key points. This is kind of like the cliff notes of our chapter, of our unit. If you'll study that, that will help you remember these things that are important to us in Unit 2 for this example. So this week, as we started out, I told you this is all due on Sunday, January the 24th, if I'm not mistaken, because Monday is the 25th. That's when I get my first shot, my first coronavirus shot. I got it all scheduled for Monday. I'm excited to get that over with. So read and study chapter 2. Download these slides and keep them in your library for this course, in your folder on your computer for this course, and use these slides as you study. Once again, we have a new topic this week in the discussion forum. If you haven't done so already, go ahead and write your response to that question and start reading the responses of your classmates. And we have 3 labs. Lab 1, 2.1, 2-1, I should say. You're going to modify the miles per gallon program a little bit, and then you're going to modify in the second lab the test scores program and look at lab number 2-3. You get to write your own program, your first program. It's not going to be too complicated. I think you'll enjoy that. Just realize you're going to use exactly the stuff that we just learned in unit number 2. Be sure and take the assignment. The Unit 2 quiz is our assignment. You have 3 attempts to get 100 on it, and that is required for your attendance. So that is what is expected this week. Does anybody have any questions before we adjourn and maybe start watching TV a little bit, see what's going on in Washington? I don't see anything in the chat. I don't hear anything coming over the speaker. So with that, I think we will adjourn our class. You guys have a great week, and I'll see you next Wednesday.
Thanks. Have a good week.
You too.